Hello and welcome to Tiny Code Christmas Day 7. So today's video is going to be a bit different. There is a challenge and it's listed on the website for you to take a look for today, but today we're just going to talk about overall size coding tips and tricks for the TIC80 and the Pico 8. So before we get into any specific tips or tricks, I just want to outline some help and resources that are available to you on your size coding journey. The first being sizecoding.org, and that is a wiki that contains loads of information about size coding on a lot of different platforms and has some great tips and tricks for the Pico 8 and the TIC80, and a lot of what is in this presentation is covered there. Next is the Lovebyte Discord. If you're not there already, it is a great place to discuss your Tiny Code Christmas work and to get help on shaving an extra few bytes off, and it's just great to see everyone taking part. Mastodon and Twitter are also great places to share your stuff, and again, if you do, and please do, use the hashtag LovebyteTCC to make sure that we'll see it. So if you're looking for some inspiration on your size coding journey, I would recommend the Field Effects Monday Night Bytes Byte Jam. And if you're watching this today, there is a Byte Jam tomorrow at 8 PM UK time. And that is on the Field Effects Twitch, and I will put a link in the description below. Next up, livecode.demoscene.org. This is an archive of TIC80 and shader live code. So these byte jams that we talked about, byte battles from Lovebyte, all of that code is archived on livecode.demoscene.org, ready for you to take a look. And it has both byte jams and byte battles. Byte jams being more freeform, less restrictions, and byte battles being time restricted and character count restricted. Next up, nanogems.demoscene.org, and this is a gallery of the best size coded productions across all platforms, so there's definitely something there that will provide some inspiration, and it will give you a good overview of the current state of the art. Some general Demoscene videos for you then, that I'd recommend that you watch if you are new to the Demoscene, and Psenough has a YouTube channel with a lot of great content, and the monthly Demoscene reports are something that you can watch every month to get an update on what's happening in the Demoscene and see what all the major releases are and all the major parties. There's also a video called What You Need to Know coming back to the Demoscene in 2022, but it also serves as a pretty good video if you're new to the Demoscene. There's also how to properly release a Demoscene production, which tells you how to package and bundle your release for submission to a competition. Then Crypt has a introduction to Demoscene talk from EMF that is worth checking out. Inverse Phase did a talk at Hope 2022, and that is a 3-hour long talk and combined demo show that covers pretty much everything in the Demoscene. And then there's some Lovebyte seminars on the TIC80 and the Pico 8, but again, spoiler alert, a lot of the content that's going to be covered in Tiny Code Christmas is also in these, so you may see something from a future day, so you're better off to save those for later. So let's talk about some size coding techniques, and we're going to focus on size coding techniques related to character limits at this point, and when we go to compression later on, we'll take a look at a separate set of tips and tricks for that. So the first thing that we can do is reduce our variables, reducing intermediate variable usage. When we have a situation like this, for example, in our plasma, we had our color out as a different variable. So we had a variable for C for color that contained some sign values, and then we plotted it here. So when you're finished your code and you're happy with what it looks like and you're probably not going to be changing it too much more, you can add the term straight in, and you see here we have reduced our code usage. We didn't have an intermediate variable. Now we still like C equals this, and then we have to put a bracket either side of it because we need to multiply it by 8. So on the whole we saved maybe 1 or 2 characters, and sometimes that's all you need. So the next thing you can do is increase intermediate variable usage. And when the expression appears multiple times, for example, in this sample we have this sine x divided by 10 plus t, by 20, and then we have sin x divided by t plus 40. So we can take the commonality here, which is the x divided by t plus by 10 plus t, and pop that into its own variable, and you can see then we will have saved a good bit of code. Aliasing then. Save characters by assigning long function names to shorter variables across multiple uses. So, for example, if I'm going to be typing mat.sin everywhere, I can alias it to just sin, or I can alias it to s. And if I need to use cosine and sine, then I can just, and maybe some other mat functions as well, I can alias m to be mat and use that as m dot, and then the mat function that I need. So the square root is something that we've used to find the distance for our polar coordinates and stuff, and raising the number to a power of a half is the equivalent of getting the square root. So mat.square root can be replaced with power of a half, and that'll save 6 to 8 characters in TIC80, and then in Pico 8 it'll save 1 to 3. And the reason for that is that obviously you don't have to use the math prefix in Pico 8, and square root is 4 letters to the power of 0.5 is 3, but you have the potential to shave 2 more characters off, because in math.square root you had to include the brackets, but depending on your expression in Pico 8 you may not have to. So obviously if there's multiple terms you will have to, but if it's a single variable or a single number you can get away with it. And again, another optimization is you can just leave off the square root and just scale the value without much of a problem. And again, you might need something to be the distance. It might not need to be the distance. You might just need to know if something is further than something else, in which case you won't have to use the square root to find that. And you can save 2 to 3 characters by using a single loop to draw instead. So for example, I'm going to go for I equals 0 to 32,639, and that is 240 multiplied by 136, which is 32,640, but we're starting at 0, so we'll go for 32,639, and each time around the loop we calculate x by modulo 240, and we calculate y by dividing 240. So we can save 2 characters on the loop by using exponent notation, which means that we'll be replacing 32,639 with 4e4. So let's take a look at 4e4, which is 4 by 10 to the 4, which is 40,000. So that is a good few loops extra. You are not going to be doing 32,000 as we saw previously. You're going to be doing 40,000. So that's a trade-off between size and performance. Do you need your thing to be performant, or do you need to shave off some characters? And if you're using pix, that will clip, but if you're using poke, it won't. So you may access some memory outside of the screen. So in general, with TIC80 and Pico 8, your entire program can be reduced to a one-liner, and you can either just eliminate new lines, or you might have to put a space in there. So for example, this is a basic TIC80 function that prints hi, and it's all on one line, and you can see there needs to be a space after function, but there are no other spaces required in this program. So hexadecimal notation is one of the things that can cause a problem when we try to put everything on the one line. So avoid using single letter variables A through F in upper or lower case, and also avoid using X, because that can be seen as part of a hexadecimal constant as well. So if we take a look at what this means, I have a bunch of variables here, GHIJ, and I've initialized them all to these values. I am size coding, so I'm going to then remove the new line between all of them and have them like all on the one line, and you can see that that does not pose a problem. I'm now adding a equal to 0, and as soon as I add a equal to 0, I'll start getting malformed numbers near, and you can see 136a. So it's after trying to interpret 136a as some kind of a hexadecimal number instead of a variable. So keywords need to be followed by a space, and do needs one before it, as the D could be hex. So if I take for I equal to 0 to 239 do, if I leave off the space there, that is going to be treated as a malformed number, and if I remove the space here, it's just not going to work because there needs to be a space after the keyword. So we can't do either of these optimizations. So now we're going to take a look at size coding techniques specific to the TIC80, and one that we can do is we can approximate the cosine using sine, and this is something that is this is something that's useful if you don't have the space to use both sine and cosine, or you don't have the space to alias cosine, for example. More of a problem on the TIC80 than it is on the Pico 8, but we'll take a look at it anyway. So this is our sine, and we can approximate it by having our angle and subtracting 11. So sine and cosine are the same thing, they're just 90 degrees out of phase, and if you go back and watch the sine code and if you go back and watch the sine and cosine visualizer, you'll see that. And 11 radians is approximately 630 degrees. 2 full revolutions is 720, so when you subtract 630 from 720, it gives you 90 degrees. So this will technically have 2 revolutions involved, but at the same time the sine of that angle is going to be the same as the cosine. And you can also add +8, but that is less accurate, but you can save 1 character, and again that will depend on how accurate you need your sine and cosine to be. So you can use the built-in load function to load your code as text, and you can omit parentheses from function calls if there's a single argument and that is a literal string. So instead of function tick brackets new line print high end, you just have tick equals load and a single quote and your code and a single quote at the end. The entire program needs to be on one line, and you will need to escape some special characters, for example backslash, that are inside of the strings. So substrings then, and this is a technique that we already looked at as part of our sine scroller, but we can use some of these extra tips here to optimize it. So I have text hello in a variable, and I can use string sub text ii as we saw already, but I also have text sub ii as well, and that will, again, we're using ini as the start and finish, meaning it will pull out one particular letter for us at a time, and so text sub will give me that. I can also remove my variable altogether and put the string in parentheses and call sub directly on it, and you can see how I might use that inside of the print function here, and obviously this print function will be inside in a loop with I iterating over each letter in the string. So now we'll talk about some size coding techniques that are specific to the Pico 8. So goto is something that you can use in your program, and in this case they are used to replace the draw function with a label and a goto. So you will create your label with the 2 colons and a single character usually, and again on tweet cards and stuff like that you might see the heart emoji or something like that being used, and your code will go here obviously, and then there's a flip function, and flip waits for the screen to synchronize, and then you can go to label and it will go. Pico 8 copies the frame buffer to the screen 30 times per second anyway, so you can omit flip if you're not too concerned about the state your effect is in when it gets copied to the screen. And if you want to use a custom palette and reorder the colors, you can use a palette maker created by 2D Array that will allow you to visually select the colors that you want in your palette, and then you can enable output in TweetJam mode, and it'll give you this lovely P8ski string that is basically full of control codes that are going to set up your palette. And these control codes, P8 ski, Pico 8 ski, are well worth looking into, because there's a huge amount of savings to be had in your character counts. So for example, these come from a tweet from Zep, Pico 8's creator, and these are some shorthand for the square root, flip, and CLS, so something that's we saw earlier with the flip, and for max that will again save you a good few characters. So it's really worth digging into the documentation on this sort of stuff if you really want to squeeze every character possible out of your Pico 8. So that's all we have for today, and hope to see you back tomorrow for the next challenge.